Okay, so here we go. What I've done is I have a sample robot. I will try to show this to you. Why not? Oh, where'd it go? Can you guys see me? It looks like my camera is on. It's trying to bring up my camera so I can see that as well. It's not showing it to me. There we go. Okay, so I'm Ryan, by the way. If this doesn't get too crazy, here is my robot, which, yes, it's lacking a lot of parts. I've got my wireless radio, just like you guys have in your kit. I've got the Robo Rio. I have a gyro with my, this is the HD, the Microsoft, the 3000, HD 3000, that I believe comes in a kit of parts this year. It also has the light ring on here, and I'm using twisty ties to hold everything together at the moment, since this is not ever going to be on a real robot. And then to support the light, since I don't have the normal power distribution board, I've got a DC power supply, regulated power supply that came from Adafruit, that I've got hooked up here to power as well. So I can actually turn on the lights without having to have the entire distribution panel. This is obviously a non-standard setup. I'm using power from various the power supplies that I've got plugged in below. And this is how I'm going to demonstrate for you guys how this is all going to work. Now, again,
hey, Ryan,
you guys have, yes.
Sorry to interrupt. Can you just check if the other people are able to see your video, because I'm not able to see it on my screen?
Yeah, I can see his video.
Okay. Okay, I believe it'll pop up when I've got the camera turned on as part of the webcast portion, since I'm doing screen sharing also. It may have to be turned on, you may have to turn to the video side on the webcast page. But are other people able to see?
On the recording screen, if you click on that particular screen, Ryan, your green screen, that'll come up on your screen share, and everyone will be able to see, and it will also show up in the recording.
We've got some that can see it, some that can't.
Can you double click on that green screen on your main, wherever you're a host?
Yeah, on the host side, I've got the video turned on and people walking by. I've got, some people can see this video. It looks like 5393 cannot at the moment. See, can anyone else not see the video right now? A 3179. Okay. Are you on? You can get the email. All right.
Yes,
just a second.
Perfect. Now we can see you.
Now you can see me with this
Yeah,
screen?
now I can see your screen.
Okay. So I believe someone that could see me before, can you confirm that you've got two videos of me now? A little one, or one to the side, as well as probably now, if you can see my screen, I've got, actually you may have three. Okay, well, I'll do a quick, just walk through on this real quick so to make sure it's in the video for my setup. Okay, so we've got the robot radio, the RoboRio here. You can see I've got 2 channels, PWM channels for the 2 servos, which are on my little gimbal. And on the gimbal, we've got the camera, and so I can turn the light off so you guys can see. I've got the camera and then the light array on the outside. And then for those that are interested, this is just the DC power, regulated power supply I was talking about that I got from AdFruit. Okay, so I'm not planning on using the camera a lot, except, oh, there is one other piece that I did not show you. Sitting on the chair over here, this is my boiler, obviously simulated boiler here. And what I've done is I've scaled the boiler size down. I took the measurements of this wonderful water bottle that's wrapped in black paper and retroreflective tape on it. Took the diameter measurement of that and then scaled the measurements that came in the kit apart, or the field measurements, to match what the model was. So, and I've confirmed it does work. So, and we'll get to that here in just a few minutes. So let me get back to screen share here. And I'm going to turn off the camera at the moment, but I'll turn it back on when we're ready to look at that in function here in a few minutes. Okay. Where did my chat window go? Excellent. Okay. Have that to the side so I can kind of see what's going on. Okay. So to start the whole thing here, what we've got is I've got a project that I've created, and I will step through it real fast for you. That's not there. So let me bring it open a long way. Desktop, documents. 0.0. So for those of you that were in my previous sessions, I'm giving you a prime example of why it's difficult if you do lots of projects and don't name them consistently. Okay, this is the one I want right here. And my project. Okay, so this is my project that I've got set up right now. And this was through the exact same process that you guys have done to create your robots to date. At the Getting Started page, I clicked, well, so on the Getting Started window here, I clicked the new RoboReel project. I set it up as the arcade drive, gave it my team number, gave it a project name, and then waited for it to create. When it created a code for me, I'm going to show you my begin, because I've added the 2 servos for the gimbal on here. So here's how I added, just like you would normally do for another servo. Now I have limited it to 180 degrees on the setup side. I did a little bit of experimentation, and since both these servos are the same, I've got a bridge between the 2. As you can see, I've named them the camera pan and camera tilt. In my finish VI, I've closed them out. So here's the pan and tilt on there. In my teleop at the moment, just for testing purposes, I have taken the axes from my gamepad here that I've got and linked them in to the position. Now, because the joystick gives out a different input or output than the input I need for the position, I had to do a little bit of math to get it to work properly with the set position for the servo. And for those of you that have questions on how that all works, we can talk about that at the end. Or somebody can ask a question, we can talk about that. So this is the launch point that I'm going to use for the rest of this demonstration here. Now, I am going to qualify this slightly that I'm expecting this to be more of a beginner of how to get the vision to work. I'm not going to go into great detail on how to make everything perfect, because that's part of your job. but I'm going to give you some good resources at the end here as well. So I'm going to launch the example finder because that's where the functional example is that we're wanting to play with today is. Go to find examples or help and then find examples. And for those of you probably already know where this is at, but here's the 2017 vision example. I'm going to bring him up. Now, there have been numerous questions on both the forums and that people have actually asked me about this. And so I'm going to go through this example before I try to implement it with my project. I'm just going to minimize my stuff right now, close out the Vision Explorer or the example finder. Now, the first thing I'm going to do, since I'm going to actually make some modifications to this project, is I'm going to save a copy of this project so that I can modify it without losing the original one that shipped with everything. So, File, Save As, and I want to duplicate to the project and its contents, and then Continue. And that's going to ask where I want to save this to. So, I'm going to copy my folder name here. I'm going to go ahead and put it in my Documents folder with all the rest of the projects. I'm going to do a new folder, and I'm going to name this the Vision Example. There should be one in here already. I'm going to call this one Live Demo. And then click OK. And so what it's doing is it's creating a copy of this project for me to be able to use and modify without modifying the existing project that's out there. This is one of the portions where people are having problems. This Calculate Particle Score VI, and I'm going to talk about that here in just a minute. But for now, I'm going to say cancel, and then I'm going to ignore that, or it's already ignored it for me. And when this is done, if I look in the support code, I have this Calculate Particle Scores with a yellow, hard to see a little bit, there's a yellow exclamation point right here. And what that is telling me is that it's got a problem. If I right-click this and click Find Colors, it tells me that no items are found. And what that is looking for is it's looking to see if that VI is used anywhere in this project at all. And since no items were found, it's not used anywhere. So it's safe to right-click it and come down and remove from project. And then click OK. So with that being done, there shouldn't be any other exclamation points in this project that we're having issues with on here. And you can actually look in the dependencies and see if there's anything in there on both of these, because if there's exclamation points or other strange things with the VIs, that has to be handled before these will run properly. Now, right off the get-go, the other portion of this that I need to do, actually just realized I had made a mistake here because I'm actually still, if you notice the title here, this is the 2017 Vision Example. This is the live Vision Example that's from NI. So what I'm going to do is close this one and open up the one that I saved just a moment ago. And when I close this, I'm going to tell it, no, don't save, because I don't want to actually modify this one because it's the one that shipped. So I'm going to go to where I saved the last one, which is in my documents, LabVIEW Data, Vision Example Live Demo. And the funny thing about this is it creates the same path that the main one comes through. So here's my project file. And there we are. And I've still got the Calculate Particles. So I'll demonstrate one more time. You right-click it, find Colors, make sure it's not used anywhere, and right-click, Remove from Project, and click OK. Now, for the first part of this, I'm going to show you the desktop version, which is this top portion up here under My Computer, the color processing example. And when we run this, you may come up with where there's no images that come up. And the reason for that is because it doesn't copy the image folder with the example. So the other portion, to find those images, we go to the default install location for LabVIEW, which is C, Program Files, x86, down to National Instruments. LabVIEW 2016, examples, and now you're going to be just like you were in the example finder. We're going to come to FRC, RoboRio, Vision, 2017 Vision example, and here's the folder of sample images. I'm going to copy that folder into my example folder here as well. So now when we run this desktop processing example, up here, hit the run arrow, now it populates all of the image files. That's not a necessary step that you have to do, but it makes it easy to kind of experiment with some of these images a little faster. And it keeps you from accidentally modifying something in the support directory that may break the example. If you break yours and want to recopy it, you still have a place to go back to. Okay, so if we flip through these, you can see it sees the target real well, and it's calculating the distance, and this is the orange one here is the grade, the score that it's giving the image that it found, or the target that it found in here. And you can go through and look at a lot of these. Now, I took a couple images of my test target, and I've got them sitting here on my desktop. One of them was real close to it in front of the camera, and one of them I've got it up high and a little further away. Now the light settings are the exact same for these two images. I'll bring them both up. I don't know if I can bring it at the same time or not. We'll see here. There it is. I've got 3 copies. But if you notice the difference between these two images, the light setting on the camera didn't change, but the intensity obviously is changed quite a bit between the two images here. So that's something that we need to be able to handle in our vision, because that is relatively important to us. Okay, so if I want to see and play with those images that I took from the camera, and I will show you how to do that as well in a few minutes, you just got to redirect the path to where your images are. You can put them in the folder that we just copied that has the images for the samples, or in my case, you can just come to the desktop, and here are my 2 image examples that I've got. And see on this first one, default, it finds it real good, and you can also see I have a piece of retroreflective tape hanging off the side of the window there. And it does see that, but it doesn't select that as part of the target. And you can see over here, it sees it in the processing as well. The second one, this default one, doesn't see that target quite as well. So part of the problem is, how do we tune this algorithm? And one of the ways that I encourage you to do is to start basically from the beginning. If we set the saturation, which is this bar down here, and about the my mind just completely went blank on the vowel. It'll come to me in a minute, I apologize. But if you set these both effectively to 0 on this top, and then you start searching again until you find your color that you're looking for, and notice over here how suddenly it went completely, I mean, it's obviously there now, but it's also got a lot of noise. That's what you're looking for. And you can tune this by down here, you can tune each of these a little tighter. So, okay, I want those bars to be solid where they are in the image. So that's a little too much. So I'm gonna come down back to 80. I've got nice solid bars there. I'll look down one more to see what it looks like. It doesn't seem to hurt me any. Having it a little further open may not be a bad thing. So let's start with the 70. Now let's tune the top side of it and start coming down until we lose those bars again. And what we're doing is we're selecting the specific color range that is acceptable in the algorithm. So I lost it there, so let's bump it back up. There they are. I'm going to go just one more for a little bit of buffer to make sure that color range stays consistent. All right, so the next section after you've got the hue and make sure that they're always included, we're going to come to the saturation. We're going to do the same thing. I'm going to start bumping this down or increasing the number until I start to lose the bars, and then I'll step away from it again, just like I did with the hue. And what I just did is I've switched from the ones place to the tens place. I'm going to increment by 10 now. And as I continue to increase this, you'll see some of this noise start to go away, and that's what we're targeting here, because we're limiting the color spectrum that's acceptable. Now, as I keep getting higher and higher, notice not much is changing in this. And what that's telling me is that I'm probably trying to tune in the wrong section. And notice I'm almost the same number down here. You don't want to be that close to each other. So I'm going to bring this back up to about 150, just for a center point. And I'm going to start playing, it's driving me nuts, but the VAL setting, and we're going to start tuning on that one. And that one's going to have a big impact as we move forward here. So notice already it's looking better and better. And notice it locked on the target. We still have a lot of noise down here because the box happened to be a Kleenex box that was sitting on, and it's white, and so it was reflecting the light real well. So as I continue to increase this, remember, we want to see how far we can go without losing our targets. As I continue to increase, see how I start to lose the outside edge of this. And I continue to go a little further. Let's go switch it to 10s. Now, what's happened there is between these 2 points is the target is round. And so the retroreflect tape reflects the most when it's pointed directly at you. And then as you go around the outside edge of the, well, in my case, the water bottle, you start to get less and less reflectivity based on that. And so that's where we're starting to see that intensity values, we're actually starting to vary right there. So you can then come to the bottom and do the same thing and bring the bottom up. So not everything is acceptable. You can actually get pretty tight on these tolerances to really select in the range that you're actually looking for. And what the bottom coming up is, now we're on the top side of the intensity. Now, you do need to be a little bit careful with this because it is possible to get it so tight that it won't work in a lot of scenarios. But as you can see right now, we've got a really nice it is identifying the reflective target in the image, and this is what we're looking for to see what the algorithm sees very, very well right now. Now, notice we still have an infinite that it's having a hard time calculating the range. Now, and I'll explain that a little bit more about that here in just a minute. But the first step on that is going to be to adjust your target itself to see if it actually ever sees it. And I saved this picture specifically because it did show the infinite range here. But let's switch back to the original image, the one that looked good initially. Notice it's not very good in this because the light was dead on. It was really great reflectivity. So we want to be able to see it in all scenarios. And this is something you need to test once you get your algorithm working on your robots. You've got to check this in as many angles, from as many positions on the field as you want to be able to see that target, because that is very, very important, as you can see from these two pictures. So what you do is you start playing with this. And in this case, let's bring this max brightness back to the top. Notice I gained some more there. Let's play the saturation a little bit. Hey, it actually managed to calculate there for a second, but we still have these blank spots in the middle. So let's play with this and go backwards with it until we get closer to our targets. Now, this isn't having an effect on the zone that I'm interested in, and I'm starting to get noise back. So I'm going to put this back to where it was at and start playing with these a little bit. Notice that still is not having a lot of effect. So what we've got is my color, somewhere in my color is not quite right here. So this was a good center point. Let's start stepping these open a little further and see, there it's already started getting better on that side of it. But we've got some noise between it, which we'll look at here in just a second. So you play with this algorithm back and forth until you find a good section or a good spot where you're seeing everything you want to see everywhere that you want to be in the target. So let's try to catch this target. Very limited, obviously, but let's get the algorithm set to where we see our target again here. And then we'll check the other image. And this is a good example of why you need to save a couple of images, because you can do this offline and not have to actually have access to the robot if you're, once you've got the camera set up You can even take the camera, just connect to your laptop and play with it. Okay, so right there we've got good, real good, and it's obviously calculating the distance here. Let's switch back to our test image again, and we don't have it. So you play back and forth until you find a happy spot effectively between the two of them. And you try playing with one, like I played with all three of them on that one. I opened up our range, I hugely adjusted the saturation, and our value here, I played with it a lot as well. So this time I'm just going to play with the value and see where, so we've got it in here, and notice it's upwards of 21, and when I switch the image here, I've still got it here. Now, notice there's still a lot of noise in the picture, but we're looking for something pretty specific in the image itself based on the algorithm, and that's how it's still able to lock on between the two. So we'll use this for right now as just a baseline, and what I encourage you to do is to write these numbers down, because you'll need them later if you're going to use this directly in your code into the robot itself. Okay, so since we have some basics, does anybody have any questions on this portion of it yet? I'll give it a couple more seconds here, and if I don't see any questions pop up, then I'll continue on here. Email never sent? Okay. Just a second. Let me see if I can find this. Okay, so 2333, I'll answer that here in just a second. Come check this real quick. Okay. Okay, check it real quick. We had a typo issue. Okay. My chat window goes away every time I do that. Okay, so 2333 asked, how did I get to here? And I'm assuming you're asking about this window specifically. Is that what you're asking about? Okay, so this window, let me real quick, right. Okay, so I'm a big fan of Notepad, especially for when something quick and small that I can quickly type. 70, 130, 3, 255, 21. Okay. So those are these settings right here for the LED color that I just typed in my notepad. I'm just going to save those down here just so for later. Okay, so this screen is in the default project. So I'm going to stop this and close it so I can show you how I get there. I'm going to say, in most cases, when you do this creating of a new project, the first time you open it, which is what we've done here, you do need to save quite a few things actually in the background. So saving all is a good idea, especially if you've made a copy of the project, like we did here. Let's take just a second to save. But this is the example project, so the 2017 example. Here we go. This is the one that's in my documents, yes. Okay, so, and that's a quick, since I did it, if you click on this Files tab here, you can see the path to what you're looking, like in this case, the color processing example. It shows it's my document, the LabVIEW, all the way down to the file itself, so you can see the path where you're saved at. But anyway, so this is the project that I saved. It's this FRC color processing example, and it's under the My Computer portion of that. I'm assuming you're probably trying to do this on your computer as well. Were you able to find it? Excellent. Okay. So there's also an example here for the low goal example. I'm just going to run this. I don't have an example set up with this one of my images. And on this one, you do have to select the correct folder. So if we come back in here to the sample images, there is the LED peg. You can select that folder. And now we've got examples of that. Now I've tweaked the settings a little bit here. Oh, these actually have different settings than what we played with even in that. But you've got the set of images here that you can be looking at as well. Now you don't have to necessarily use this low goal example. And I'll show you here. This is the one I just had open. And we'll set my numbers in here. See if we work. 70, 130. 24. Run this. So with my tuning settings, we're still getting good results on the defaults. And this is the LED boiler. But let's switch this over to the peg flex folder. Okay, open them. The squeaking guys are hearing is there's a door right next to me and got people coming in and out. The difference between the algorithm side is the portion that's actually calculating the target portion of it. So obviously for the boiler, we are looking for the two stripes on the top of the boiler. And they're oriented in this manner. The LED, or for the target for the pin and for your pegs, or that's surrounding the peg, is side to side. And so our algorithm will be on the back side be different, and that's where it's going to be for this to be able to identify the target itself is where it's going to be. Is everybody still able? I'm getting a message on my end that my internet connection is unstable. I'm just going to continue unless somebody starts complaining. But we'll keep going here. So that's the difference in the back end, and I'll show those algorithm sides of things to you in a few minutes. For right now, I'm going to stop this, and we're going to look at the code. So on the back end here, and all I'm doing, I'm selecting the front panel, Control E to bring up our code. And I'm going to minimize my chat window here for just a minute, so we've got a little more screen real estate for this. And what we've got is, if you wanted to create, or if you wanted to modify this, this is set up to run specifically on a computer. But you've got all the same steps that you have on the inside of the loop anyway, that you have in your project for the robot. So effectively, this is where our image is coming out, and it's called laptop read. And then we're doing, this is the correct, this is for the calibration portion, which is correcting the lens perspective distortion. You've got your color thresholding, then you've got your particle results coming out. We've got the best group VI and the distance VI, and all four of these specifically are used in your robot, or we are going to be using the same robot project, and like I'll show you here in just a minute. The annotation portion, I believe, is there as well. I don't remember if the normal ones are not, but we'll look at it here in just a minute and see. But this project, this template could be used if you want to run your own code. You can modify this section in here, and that's going to be your algorithm section. Let's come back to the front panel. I'm just going to close the block diagram and minimize this one right now. I want to look at the robot code portion. So one of the questions that I get occasionally is, how do I get this to run on my robot? Because this will actually run on your robot specifically. Now, I know this code works. This is my project that I set up to run the servos. Specifically, if you notice, my addresses here for the target are different. If you come to the one that you created and that you've already got tested, or if you have one, you come down to the properties, it has the IP address, the DNS name, and that's what you need to copy across. So I'm going to copy this, click OK, and come over here to the copy of the project for the vision, come to properties, and change the IP address name in here. and click OK. And now I should be able to, if I make sure my wireless is connected. And for those of you that are about to freak out, I actually have two Wi-Fi cards on the network. So one of them I've got connected to my robot radio, and one of them I have connected to the internet, which I'm talking to you on. So just making sure the one for the robot radio was connected as well. I can now right-click and connect. Right-click and connect. And I've got everything turned on already except for the light. It'll actually deploy out to my robot. And there we go. Deployment successful. So we want to look at this project now from the RoboRio. A couple of things we need to do is you actually need to build this project once. Because there's a couple of files that if you don't, and specifically this calibration file, is not out there by default. And the only way to get it out there is to build it and deploy it. So I'm going to build here, and I'll continue talking while this builds. This calibration portion, if you're worried that it's not being set up properly, there's a white paper out on National Instruments, and there's some camera for the DAC and MAX image acquisition such about how to calibrate these cameras. And if you actually look at this image, which I can show it to you real quick, is what it is a grid of dots that are all spaced the same, and the dots themselves are the same size. And so what it uses is the calibration algorithm looks at these, and it knows the spacing, and it knows the size of the dots, and it analyzes that, because you can, if you look at the picture, you can actually see a little bit of distortion in it. There's also a little bit of optical illusion going on with it as well. But there is image distortion based on the lens type. And so it helps to take out that lens distortion. And I'll show you that here when we go to live on my simulated target here in just a minute to actually see the difference in the calculation for the distance. Okay, so the build is done, and I'm going to go ahead and deploy it. And I'm not setting this to run at startup right now because this is just a test VI, and I'm not really worried about it running at startup because I'm not planning on turning it off. What I'm worried about is making sure that my support files are there, specifically that calibration file is on the Rio itself, because that'll give us an error in a minute if we don't. So now I bring up Vision Example Robot Main. And this is going to look a lot like our robot itself. And we have the normal buttons like we normally see. I'm going to show the block diagram, Control E, and here's the block diagram. It looks a lot like our robot. There's a few things missing. Specifically, if you look in here, we only have a finish and a default in here. And that's different. But we do have a vision processing VI. Let's open this vision processing VI and take a look at it. So the phone number to call in for your audio, I believe, Ray, if you want to jump in, or are you on webcast now? On the splash screen, if you click on the join audio, there's like a headphones. Does it give you a phone number on there? Yeah. Okay, so if you bring up the main webcast screen, there should be a little picture, like a set of headphones. If you click on that, it should pop up the call-in number. Did that work for you? That's the 2765. Tried both numbers and they didn't work. That is how I'm dialed in. Did you make sure you got the area code correct? Because I dialed it the first time and got the wrong area. So I used the wrong area code. Let's see here. I don't know if I can bring it up. I can stop the screen share real quick. Because you've got to use the participant, the participant ID as well as our meeting number, and then you've got to have the participant ID, which should be in that window as well. No, that's not the number that I've got here. Just a second, let me bring it back up. Here's the number, just take the chat number. There's the dial-in number. Let's see, I'll do this right. Oh, hang on, I'm not doing it to everyone. Okay, so that's the dial-in number. This is our meeting ID. Oh, there's the meeting ID. And then you've got to use your participant ID, which you can get from that join audio button. You should also be able to see it beside your name. In it, it should say your name and then participant ID, I believe, if you look at the participants list, to be able to get the audio. Well, that's for you to be able to talk. I think there's also oh, I can mute you on this end too. It doesn't auto mute you when you call in. Let me know if that works. Okay, so back to screen share here. Excellent, okay. Okay, so this is the vision portion of the robot. Let me back up just to make sure everyone's with me. So this is, we'll save it, I have to save it anyway. The vision example robot main, and this is still in the example 2017 vision example, and this is a copy of it that I made. So the vision example robot main, here's that one, Control E for the block diagram, and then the vision processing.vi file. Now it looks a lot like that example we were just looking at a minute ago. The only difference in this case is that now we don't have an option to look at files because we're going to be actively connected to the camera. Now, a couple of key things here to remember. On the main, your vision does need to be enabled. So that's number one. The second thing that we need to think about, or that we need to keep in mind, is that when I run this, it's going to, whoops, I've run in the wrong place. Cancel here. You don't want to run using the arrow from up here because you're not running the full robot code. You want to run this just like you would your robot main from the robot main VI. So you're going to hit out here, and it's going to ask I've made changes, click save. There we go. Okay. So 2765, I just muted you from my side because I was hearing a little bit of the phone noise. So if you need to talk, let me know. I can unmute you. Okay. So the deployment process on this is complete. And click close. And now notice that it's running on this side. But we don't have anything out here. But see that we've got the arrow here at the top that shows that it's running. So now I'm going to click the display original, and now we've got a picture. I'm going to show display mask, because we're going to need that here in just a minute, and that shows you the algorithm processing portion. Now the next thing, I am using the MS, the HD 3000, but I'm not using the square. I'm using the 640 by 480 portion of it. So I'm going to select that to set that correctly. And my calibration still failed. I was hoping to avoid that. We'll troubleshoot this here in just a minute because you guys may have that same issue on your end. But we are effectively processing. Now, the reason we don't have much here is because I haven't turned the light on the camera. So I'm going to reach over here, turn my light on, And voila, we have at least the target is illuminated. I'm adjusting the gimbal just a little bit to make sure that we've got it somewhat centered as we start playing with this. Actually, I want it a little on the low side right now. So remember the settings that we had saved earlier. Here's the settings down here in the bottom corner. I'm going to type these in. 70, 130, 3, 24. And there we go. So it sees the target. It is flickering between infinite and not infinite. But really what I'm looking for right now is testing the system. Are we connecting to the camera? Is it seeing the image? Is it starting to process the algorithm? And to know that it's processing is this screen over here. I've got nice red bars that's telling me that it's there. On this initial default portion, if I shift this around and I'm just holding, actually let me turn the camera on so you can kind of see what I'm doing here with this. Okay, so I believe that probably popped up a window for you guys. I can also, I don't want to stop the screen share. So if you're having problems seeing the video, I believe it comes up. Did it come up for you? You can see my face? Or through the main camera? Okay. Okay. So are my, I think I actually can see it here. Yeah, it should be real small. So my chat window's on top, so it's not letting me see that. Okay. So I'm going to show, no, it's all real small, and I apologize. I think you can actually click the video and make it larger. Try that. You click the video specifically. Yeah. So if you click the video, it'll make this larger. So all I'm doing here is shifting this back and forth a little bit. But then I'm also going to tip it forward and tip it back. Now you normally won't get, you should probably never see a tipped forward orientation of the target. But as I'm moving this, you can see that the shape of those bars changes kind of significantly based on the orientation I have the bottle in. Now, one of the things you need to also remember is mine is scaled down significantly from what your actual target is. But notice here, if I've got it pretty straight, it starts flipping back and forth. It starts identifying the target better. And if you think about this, you'll never ever see this target head on. I'm crooked here, sorry about that. But you'll never see this target perfectly head on because your robot's going to be below the stack, which means it should be tipped back. And to a large degree, it should be probably significantly tipped back unless you're far away on the edge of the field. But I'll show you how to adjust that sensitivity for the distance portion of it here in just a minute. For now, I'm going to shift this back, try to get it somewhat squared. Find a pencil to stick under the edge of the bottle so it's in a tipped back, although not hugely tipped back orientation. Square that. We'll use that for reference at the moment. Okay. I'm probably not going to touch that for a few minutes, so I'm going to turn the camera back off. All right. So what we've got then is the algorithm base, it's working. We still have a couple of things to look at. First is going to be this calibration issue. The calibration is important because without it, or if you want to use the camera for range finding, you need to have a calibrated, or you need to calibrate your camera to make that work properly. And when I was doing the testing earlier today with it, with a calibration enabled versus with it disabled, I was getting approximately 5 feet difference in the range finding capabilities. So 5 feet is enough to miss your target unless you're always not calibrated, which is okay. If you're always consistently not calibrated, then it's possible to use that even though it's a 5 feet off to get the acquisition and actually make it work. Okay, so let's look at what the possibilities are here on this of why it may not be able to find the error. First, let me stop my code. Let's click the finish button here. Because the way this is set up, and I'll look at it in here, is initially we're getting the calibration file. And I'm sorry, I didn't say what I did. I'm on the front panel, I hit Control-E to switch to the block diagram. This is, I know this because I've been looking at it and playing with this most of the day, but this is our calibration file, and this is the location it should be saved or being loaded to from on the Rio itself. So what I can do here is let's check to see if we're getting an error at this location. And so I'm going to simply create an indicator. And the reason I can't check this with it running is because this is outside the loop. This is our while loop, and this is what runs over and over and over. This is part of the configuration, the initialization side of things. And so it runs once and then doesn't need to run again. So let's look at this error and see if we get an error there. Now, there's the new error out that I just created. And I'm going to come back to my robot main and start it. I made a change, so I have to save it. It's successful. Click close. And notice we've got the error here at the very, very beginning. And so what that points to me is that that image that I hoped had saved out to the Robo Rio is apparently not out there where I thought it was at, or where I thought it might be. So let's take a look at that. So come back out here and stop the code. Now, to do this, I have to actually look at the Robo Rio itself. Well, there's two things. The first one I'm going to do is let's try to rebuild this. I've already built it, so let's, well, we'll go ahead and rebuild it since we've made a couple of changes here. Shouldn't take too long. Done. Okay, I lost my connection. Let's deploy. I'll reconnect to it here in a second. And this message is there's already something running. If that's okay, I'm going to apply anyway. That says I'm successful. Let's close. Let's come back out here and rerun this again. So let's look at the front panel, and close this for the moment. I don't need it in a second. Let's run this again and see if it picks it up this time. And successful, so I'm going to click close. And now it's found the image. So we can look at the differences here. If I can find a sweet spot on this, we'll talk about the targeting portion itself here in just a minute, where it actually gets, all right, if I can hold this stable, we'll try it. So when it flashes green, you're seeing about 17.3 feet. When I click use calibration, come on, there just a second ago, where did you go? Well, first of all, it's not wanting to find it at all. So obviously this is a problem. So let's go look at the sensitivity of this particular setting. And what this comes down to is a sensitivity setting in the algorithm itself. Now, this one we can look at while it's running. So I'm going to Control-E on this block diagram, on the front panel. Let's start looking at things that probably have settings. Well, first of all, we have a threshold LED for the LED color, which is basically reading it from here. We're doing most of the inputs for that. Not too worried about that. What I'm looking for is places where it might be doing algorithm stuff, or maybe grouping, or converting coordinates, or normalizing. So let's look at this first one, the group VI, and see if there's anything in here that has anything that we can control effectively. So there's sorted data coming in, and there's score cutoff. let's look at what score cutoff might have, because I believe score cutoff has a control on the front panel here. Our score percentage cutoff is set to 70%. Well, our legend is the score percent right here, shows it in orange. We're running it in the 80s and 90s, so we're not being cut off at this point. So that one's okay. Let's come back in here. What else might be a control? Our sorted data, if we look where this is coming from, the sorted data is coming directly from our the particle measurement VI. So that really doesn't have anything to do specifically what we're looking for. If we look at the rest of this, there's no other inputs to this VI. So, well, that one's probably not what we're looking for. So let's look at the distance. And, well, that one makes sense simply because we're actually looking for the distance measurement. Now, the first thing I notice when I'm just looking at this is things are flashing. So it looks like we've got this screen and then suddenly it goes to 0. Same thing up here. We've got things flashing back and forth. Now, from messing with this previously, I happen to know that I need 4 edges for this to process properly. And if I can get this to, if I can have both of these up here, I'm going to shift this so you can see both of them at the same time. My calibration is turned off, so I should be able to find that sweet spot again where it actually measures it. And tip this back, roughly where I was at a few minutes ago. See if this will actually bring it closer. Here we go. Okay. Now, I'm not going to be able to maintain this for too long here. But if we notice here that when it's got the green, there seems to be a lot more measurement. And as I was saying earlier, I know that there should be 4. And remember, it's 0 index. So if we start incrementing this, 3, now you can see when that third one's there, we have a green box. When it's not, it's not. So what could be the issue that could be causing that? So we start looking at this algorithm a little bit of what's going on. We've got lots of stuff coming and going. We've got edge options, the image reference, the line, those 3 controls specifically, and then we're doing some output information. Let's look and see what's connected and what we have easy control of. I'm just going to make this a little smaller. I'm going to minimize the front panel here, and we're going to come back to where this is being called. So this is back in the vision example, the vision processing VI. And sorry, I've got that. Sorry, but it's hard to say. I'll just shrink the window. Maybe. Here we go. Okay. So we were over here on the right, and this is the VI. Notice we've got the image SRC, we've got the line, we have camera type, and calibrated. Are the 4 items going in. We have the image SRC, the line, and calibrated. What was the last one here? And the camera type. Looks like we're not, here's camera type over here. So the other control that we've got though is this edge options. So for me, that's the first thing I'm going to start looking at. Let's look at this. Edge polarity, kernel size, width, minimum edge strength, interpolation type, and data processing method. This minimum edge strength would be something that I would start to think probably has something to do with the algorithm. So let's start playing with that just a little bit and see what happens. If I lower this down, I just did it by 10, and suddenly we have values relatively consistently here. Let's move our target again, and I'll turn the camera back on so you can see this. So where I can see roughly what I'm doing as well. Okay, so we've got it set to the minimum edge strength set down to 20. We've got a nice target here, and then here's my bottle. As I start to move this around, notice it's not doing the flickering anymore. So that seems to be something that by modifying it has helped us be a little more consistent. Now, something that I would encourage you to do is if you've got access to a field, or if it's something that we think might have an effect, change our lighting conditions. And so I'm going to actually set the bottle down. I'm going to turn off our ambient light here and see what happens. Did we lose the target at all? Does it seem to get better? Did it get worse? Because ambient light with vision has a real effect. Turn our light back on so the rest of the room can continue with what they were doing. So that has given us a better lock on this target. So let's tip it back. Okay, we're starting to get a little bit loose. I'm also not as square anymore. Back. So it's getting a little faint and it's getting kind of close to infinite. But also look, it's telling us that we're roughly 18-ish feet away. I tip it back forward a little bit. Let's turn this calibration back on and see what distance may have an effect here. That says 15.3. I click the right button. 13.7. Now, obviously, my bottle's not 13.7 feet away. I mean, there's my camera, roughly the camera edge, and my shoulder's in the way, but you can see my bottle. I can touch both with one hand. However, remember my bottle is scaled way down in comparison to the actual target. So in a simulation like this, these numbers, you can't really measure them. But on your robot, if you have the stack set up, this is something that you should start looking at and measure. How far am I actually from the target? How accurate is that number? How much can I rely on it? If I move positions on the field, if I'm closer to it, remember, if I'm going to be closer, ooh, you can see the bottom of the bottle, it reflects. I'm going to be probably somewhere in an orientation. Oh, I think the pictures I've seen look at something along these lines, depending on the distance and the angle and stuff. And I'm not sure you can be within 7 feet of this particular target because I think it's 8 feet off the ground. So something to think about. But again, that's running functional. That is functional right there. Let's see here. Are there any questions on what I've done so far? Okay, I'll watch the questions here. I'm going to go ahead and move forward a little bit more. Okay, so now the next question comes. We've got this example. We've got it now calculating a target pretty well. How do we actually make this work in our robot code? Because, yeah, the example's good and everything, but I really need to go to use it with my robot, with the rest of the program. Because if we remember, we come back here to the main, there's not much in this program. I can't program my robot from here. Now, specifically with this example, this vision processing VI, that's what we're really going to be focused on. So I'm going to minimize everything else, or minimize and or close if I can, everything else on this vision project, on this example project that we're not using right now. Now, one more thing before we move on, this minimum edge strength, we need to be able to change that on demand. So here's the edge options. It's already set as control. Here's the same edge options. If we come up here to the top, is that wired out anywhere that I can get access to that VI? And it's not right now. So I'm going to select an open place, like on the top of this VI. And notice that it's changed the wire reel because I'm going to wire that location to this control. And now, if I save this, file and save, if I come back to the processing VI, so now here, I now have a new control called Edge Options. And I can right-click this and create a control. And now here's my Edge Options. And I'm just going to overlap these because I happen to know I'm not worried about these instructions at the moment. I am worried about these Edge Options. And let's see, let's move these around just a little bit so I can get my Edge Options a little more accessible. All right, so this now gives us access to that minimum edge strength. And this would probably be something you want to either write down or remember what it is, because you're going to want to either have access to that from your front panel or at least set it as a constant and remember where that's going to be set to. Now, if you want to leave it as controls like this, that's fine. But to get that value to stay, you're going to need to right-click it, go to Data Options, and make current value default. And what that's going to do is, as a control, when you shut down the RoboRio and restart it, that control will keep the same value. And you can do the same thing for these other buttons over here for the displaying and the mask, the original and the mask. But we're going to be actually moving this over to our algorithm or our vision processing in our robot. So here we go. I'm going to, like I said, I'm going to close the rest of these VIs because we don't need them open at the moment. I'm going to move this to the side. I'm going to minimize it so I get the rest of the stuff closed. Okay, so that's the one we're actually working on. This is that project. Since we've made changes, I'm going to save all on it. I'm going to minimize him down. This is my robot project. And let's go ahead and connect him up. And of course, I've got to do some redeployment here. That's okay. Access is denied. Another project is using the target. Okay, so let's come back to our project over here and let me right click it. Whoops, cancel. Right click and close. Right click and disconnect. Now we want to connect over here. Now something while this is connecting, I want to caution you guys on. I've got 2 projects open, and the main reason I've done that is because I've looked. There's no duplicates of VIs between these 2 projects. And what I'm talking about when I say duplicates of VIs is if you look at robot main.vi, over here it's called vision example robot main. If I'm looking at my support code, I've got camera types. Actually looking for team code here. We do have 2 vision processing VIs, and that potentially can cause us a problem. So what you want to do is make sure when you open your vision processing VI, that the right one is actually being opened. And if you get an error saying that it's already opened, you need to stop, close everything back down, and and hopefully you saved before that point. Close everything down, because what that project has done is it's cross-linked to it's trying to cross-link your 2 folders or your 2 projects. And if you get into this cross-link situation, one way that you can find that out if it has happened is look in your dependencies. Your dependencies for your robot should be relatively self-contained. So we've got the VI lib, which is normal, and we've got some DLLs, which is all normal. If you have vision processing down here, that's a problem, and you've got to fix that. And one of the ways that can be done is if you right-click the VI and go to Properties, you look at the path that it's pointing to. And if it's the correct path, you probably can simply move it up there where it needs to be. If it's the wrong path, then you need to close. You close the VI, you'd right-click it, and remove from project, and click OK, and then go find the correct vision. Let's see, I need to come back all the way to my project here, and we can see what my project is located. The LabVIEW data vision test 1-01. So it's right here. We're going to go to, there's my vision processing VI. Bring back my folder again. Grab the vision processing and drag it back to where it belongs, and then let the folder where it belongs. Back to there. Now, when you open it, or if you go to Properties, it should show from the correct location. So you can look for that if you get cross-link files and any of this stuff, and you need to correct that, because what can happen is you back up this project and move it to you went from your developer's computer to maybe you're going to take a different computer to your competition, and you backed up all your code. If you had a cross-link file, you may have missed that file, and that can be it could be a huge disaster if you get to competition and suddenly you're missing half your project. So just be careful when you have 2 projects open. In most cases, I encourage you not to do it in general. Okay, so back to where we're at. We've got our vision processing VI, which I've got open down here. Let's see. Oh, I've got one more VI open. This is the desktop version. So let's close this because we don't need this right now. All right. So here's the vision processing VI that we were just working with. Expand them back out a little bit. Actually reshape the window size all the way around. Minimize the chat window. Okay, So what I'm wanting to show you here in just a second is that how to make this work is actually not crazy complicated. So our vision processing, now granted this front panel portion looks very, very different. I mean, that's real nice, got a lot of indicators, got a lot of control options. This is pretty blank, but we can actually copy a lot of this across and get it to look pretty much identical. But let's look at the code before we even start that process and see what looks the same and what looks different. So I'm using the Control-E shortcut to toggle between the windows, and I'm not telling you that every time that I do it. I apologize for that. I will try to do that a little more consistently. Okay, so here's the default robot main, or not robot main, but the vision processing VI that comes with your code. Now let's look over here, scroll to the left so we can see the beginning portion of it. If you look at this, this looks pretty, there's some sections in here that are very consistent. Look at this specifically right now, and look at this. They're almost identical. And the differences could be set the same because all the controls are there. The first difference that we've got here is our frames per second. Down here, we're set to 10. Up here, we're set to 12. If you're starting to get jitter, if you're starting to use your vision, you could actually reduce, this is the default set to 12, and this one's set to 10. You could reduce it down to 10. You could even reduce it less than that if you need to, and that would potentially help your vision processing. It may slow the images that you get and the response time of your visions, but it may speed up sending it to the front panel. And it may reduce jitter on your robot between the driver station and the robot a little bit if you're getting bandwidth limited. The other option that's different is our auto for the set WB, which is the white balance options. Down here, it's fixed fluorescent. Up here, it's set to auto. This is something you need to think about maybe a little bit for competition. What is our light source going to be? You can look at some of the options in here. Fixed indoor, and there's options for fixed indoor 1 and 2, fixed fluorescence 1 and 2, hold on current, and custom. This would be something that I would encourage you to test. And it may be something that you leave it set to auto and see how your algorithm works in the difference between indoor with fluorescence versus outdoor with the sun, and see if it's consistent. Because if it's consistent, you probably don't need to do a lot. If it does get a little ornery on you and it starts to change consistently or change significantly to where you have to retune algorithms, this may be something you need to check and try to figure out when you get to competition. That field setup, those testing you get to do on the field, prime place to check and maybe modify that if you need to. But if you look for the rest of these, they look pretty much the same. We've got custom for the exposure with a 5. We've got 40. And I think I may have changed this 5 on mine. I may have changed my exposure down to 5. I don't recall specific. I don't think I modified it here. I think I was playing with it elsewhere. But you've got the compression. You've got the brightness. Now notice one difference here is the names are slightly different. The MS HD camera versus the camera. If you are if you are going to try to do 2 cameras, you would end up with 2 of these in here to set up the cameras potentially. If you're going to use an IP camera and stream it directly to your driver station, then some of these settings may actually be on your driver station side and not on for that IP camera may be on the driver station that you use, copy this, and actually set it up on the driver station instead of on the robot here. But if you have another USB camera that you're going to be using, this whole section would have to be copied. And I'm actually going to try to test that here in the next couple of days to do 2 USB cameras and try to get it to where both of them show up on the dashboard side by side, because I've seen a few questions about that as well. But for today, we're not going to go there yet. So the rest of this stuff is all things that could be easily copied across. So our call template for that calibration file, well, that would be something that needs to be copied. Our IMAC references, if we're wanting to use this exact algorithm, would need to be copied across. But that's all pretty easy to do. So the rest of this portion, we've got the enable vision, the update status, and the get image. They're the same between the 2 of them. If you see this portion here, this set image size, but actually just changed a little bit. It's right here, and it just moved around just a little bit. So those are all things that can be easily copied across between the 2 systems. And so let's start playing with that a little bit. Now, granted, the window's larger, so the first step is let's make this window larger. An easy way to do that is if you hold down Control and start to drag, actually expands out your window in whatever direction you need it to go. If you need to go in reverse, if I hold the right keys down, if you hold down Control and Alt at the same time, you can actually compress it back down. Just a little bit of a LabVIEW shortcut for you. All right, so let's start at the beginning here, just like we'd normally do. There's not going to be anything that we need to modify in the begin or the finish sections of the code for this to work. So let's see if we can get this done quickly here. I'm going to expand this up. Ooh, not there though. Expand it up here. Give us the room, and I'm going to copy this across. And I've selected it. I'm literally going to drag and drop it over here. I'm not using Control-C, Control-V. Sometimes with LabVIEW, that can actually cause problems, the copy and paste. And that's why if I've got the two VIs open, I just select and drag and drop. So now, if we're going to copy this pretty much exactly. We're going to move it across. This needs to be rearranged a little bit to kind of match our example. And I'm going to delete the note just so it's out of the way. Now, the next thing down here is our calibration portion, but for this all to be hooked up properly, we need to look at see what we've got going on. We've got this color IMAC, and it goes into the get image. We have a primary image that goes into the get image, so we don't really need to reproduce that portion, but we do need this mask. Copy the mask across. Let's wire him at least to the frame edge. Now, something else that we've got here that we don't have anywhere except if you look in the false case, there's a timer. They're controlling, or they're measuring the loop count with this right here. So let's go ahead and copy that across, because that can be, especially with vision, that can be something that can be very helpful to us to be able to measure. And notice we have an overlap. We have an overlap right here. It kind of adds a shadow. I'm going to just adjust the window frame slightly using the Control right here on the very edge and drag it out just to get a little more space that drops without overlapping. One of the things is if you can make your code neat as you go, it will help significantly in troubleshooting later. And I can, from professional experience here, I can say I've cost myself and saved myself hours in both directions for the better and for the worst by doing or not doing this when things came down due, or if I had a bug that I needed to find and couldn't find it. Yeah, it can be a big deal. Okay, so now we're going to start getting into some of these controls here as we copy this code across. And if you've got, like in this case, if I just want to copy the center section, you can get it, and I've got things included and not included that I want. I don't really need the color mode yet, but I want to use the calibration. If you hold down Shift, you can start selecting. Now notice you do need to select the wire as well as you do. I don't want color mode right now, so I'm going to unselect that. I don't really need this piece of wire sticking out yet. I'll need it eventually, but we'll get there. I'm going to go ahead and include these two pieces of wire, mostly for demonstration purposes. And let's go ahead and include the tag as well in all this. All right, so got it. I'm just going to drag it and drop it across. And I'm going to line it up close to what the other one was, at least pretty close. And there's my image out. I'm going to connect the wire here. And this wire came down like this. Now, notice I've got the little weird bend. You can actually select the bend. You can get it to go to the arrow and use your arrow keys just to move it up and down, left and right. And same thing here. I'm just going to move this down just a little bit more. We were kind of tight down there earlier. And I've got lots of room. So I'm going to need this mask, and I can move this the same way. I can select it, use the down arrow, use Shift and down arrow. It actually moves it more than just a single space. Okay, we're just going to continue copying this across. The next section is the color mode and the LED color we're going to need. So let's select this portion. And I'm going to actually select more of the code this time around, at least until we get to, now I'm going to actually limit it again. Let's get rid of the limit. We need LED color. We want the wire. I need the color module this time. And we'll go ahead and get the output on that one. And we're going to just keep building this code all the way across as we go. And connect up things as they come. Now notice that I caught a piece of wire here, but I don't remember where it went or what it was going to. If I look, it's part of this portion that's connecting across. And it connects all the way over here. So I'm not going to worry about that just yet. So I'm going to just delete that piece of wire at the moment. One that is connected is this one here. And it's actually coming, if we look back over here, it comes all the way to over here. So I'm just going to connect this up. I can get it to select. Now, again, I'm just going to move things and make it look relatively neat. Neat code will help you troubleshoot it at some point, probably sooner than you expect, especially as we start playing with this vision stuff. Now, I've got a piece of wire here. I don't know where it goes. Let's look at it. It's part of this going over to the distance calculation. So let's go ahead and just delete that for the moment, since we don't have the distance here yet. And we're going to continue to build this. I need a little more room, so Control, and just expand the window a little bit more. And we're going to continue selecting and building this as we go. The next portion is this guy. See if I can get it, everything that, oh, I had the wrong button pressed on the keyboard. I had Shift instead of, I had Control instead of Shift selected when I tried to select particles. That looks pretty close there. Something we need to look at is what is coming out. And we've got this constant up here, so let's grab that constant also. I think it's going to let me copy those across, but we'll see in just a second. And knowing that it's going to go up, let's drag and drop. This one, it drops it just a little bit below. So we'll drop this. And added that to up into the top of the window, but that's okay for now. We'll go fix that. If I look at my placement, my particles was just below this air erase. So I'm going to bring it down a little bit and just try to get an approximate position similar between the two. Now, we start looking at this for connection. We're connected from the output of our threshold to the input here. Let's be this wire here to here. We've got the green one, which is the use calibration, which goes across the top, which so I'm going to delete that for now because it's not being used. We've got our image, which again is going across the top, which we're not going to use. We do need to get this guy connected up here. And they had him on the outside of the loop, so let's duplicate that. And we can bring this back in by just using the tabs this time. Come to the output and wire it on in. And wire it all the way across. Now, we're a little mismatched. I'm going to fix it. And you can use the select tool, the drag to select, like I did there. And I was just holding Shift to make that selection. Okay, so we've got everything connected in. We've got the particles, the size limit, got everything for this and the false. And just continue to copy this across. All right, so the last portion, I think we can probably copy all of it in one go. Let's select all of this. And you could do this in larger chunks than what I'm doing. One of the things you just got to be careful of is know what's being copied. And remember, like right there, I made the selection, but I was not looking real close. The camera type did not get selected. So let's hold Shift and get the camera type. And we need our score cutoff. And if we look at this to make sure if there's anything else we need, remember we've not been copying these two, but we'll copy them. We'll create those wires here in just a minute. Let's drag and drop this up here. And it looks like it should go somewhere along these lines. And when I let this go, if you notice the shadows of what we've got selected go beyond our loops, it's going to expand that loop for you. So you don't have to worry about stopping and re-expanding it. Now, it may be really, really tight like it is here, but you can use the Control and drag out your window a little bit for both of them if you need to for a little more white space. Okay, so let's go ahead and connect this all up. Get that. And bump them down just a little bit. Got a broken wire, so let's look and see what that goes to. No, I missed the line border, so let's go get the line border and bring him up. And we're going to connect him in. Okay, one of the things that I'll a lot of times try to do is kind of move the controls and such a little bit closer to where they are, just so that if I'm modifying this, I can find them a little bit easier. Okay, so let's continue to look at this. Now we've got to connect up our image. If we match it, it comes all the way over to here. So we make that connection, and then we need our enable, disable, and the calibration the same way. Now, it may reroute your wire funny, but you could just simply drag it to where you want it to go. Make it either match or to whatever your preference is. My usual preference is the least amount of bends, the least amount of wires crossed. Makes it the easiest to read. Okay, so we've got, looks like it matched between these two for the distance, for the group. It looks like we've got pretty close. Move my camera touch to offset it so I can see that a little easier. As we look on the output side here, we've got some broken wires. So let's look and see if we can find where those wires are broken. We have the results coming out here, and it's telling me that you've connected terminals, or 2 terminals of different types. Type of the source collector is 4 elements. The type of the sink is void. So what we've probably got going on here is an issue in one of our outputs. So this one, we can look at it and see, is pink, and so we're good there. The results isn't really listed, but let's see if we can find something else that looks different. Notice that the color and the weight of the wire here is dark, and this one is light. And you can actually test this. Like in this case, I can delete it, and suddenly everything's good. If you weren't certain that that was it and thought maybe it was the results, you could delete that. Oh, it's not fixed. Connect it back up and try the next one. Let's delete that here. Now, what's going on is our global variable doesn't have a value called vision results. And if I come down here and double click it, you can see we've got a lot of different things, but not, and for this one, we've got one called vision results. Up here, I don't have one called vision results. If I right click, and I believe I can open this from here, open the front panel, we've got one called enable vision, image size, and null seconds to process, and one called vision results. So let's do the same thing over here. Let's right click and open the front panel. And we can drag and drop our vision results the same way we did earlier into here. Now we close this and say save. This is the one from the other project. We're just going to close that. Now notice it has turned pink. There's now one called vision results, and we can wire that in. All right, is there anything else? Looks like all the rest of this is the same now. Look, our run arrow is now white, which means it could run. I didn't mean to click it. What about habits? Your run arrow, I've got to click it just to test it. Okay, now for those that know me real well, I am a big, I like white space. However, too much white space will drive me just as much nuts as not enough. And so I'm actually going to just compress mine down just a little bit. Again, you don't have to do this, but I will. All right, so we've got the algorithm implemented into the vision, into the block diagram. Let's take a look at what the front panel looks like after we've made all those modifications. Still not quite the same. Look at this one. This is nice and pretty, and so far this one looks kind of a mess. That's okay, because what's happened is we've copied a bunch of controls and we didn't place them in any specific order or location. You mouse over a little bit, it actually didn't do too bad. It's just things are on top of each other. So let's start to clean this up just a little bit. It can be something as simple as you find things are starting to overlap. If you do a big select, notice the shadowing of the selection tool here. So I can do the same thing. I can hit Control and deselect things that are not captured. I don't need this one right now. I want to keep him there. And start using the mouse keys to shift things out from underneath. Notice I've got too much selected. My distance and score tags are moved. So Control Z to undo. We can shift and deselect those as well. All right, it looks pretty good there. Now our image size control was located over here. So let's just drag him roughly located. We've got one called line border up here. And and there's our line border there. So you can make them look exact, but you don't necessarily have to. And then our error, no error in, and no error over there. And if you double click it, it goes on to the VI into your block diagram and highlights it there. And you can do the same thing to go back if you need to. Bring this down here. Okay, now we've got the screens look pretty close. They're not perfect, and I'm not going to spend the time to make them perfect right now. If you want to or need to, I understand, and you can do that later. For right now, let's check our code, see if this actually will run. Remember, we've got to make sure that we're selected properly. The camera type, you right-click, and data operations, make current value default. If you're not using the MS, the HD3000, you can use whatever the selection you need to on that. Specifically, that has to do with the calibration portion. If you're not using the Microsoft one, and if your camera is not in the list, you do need to calibrate your camera. And so that'll be something that you'll need to do, not right this moment, but will definitely need to be done. Okay, so like we did with our other one, I'm going to minimize this one over here. I'm going to actually deploy this to our robot. Something else that we do need to copy across into the project at least, that's not in here right now, is a sub-VIs. So remember, we were talking about cross-linked files. Right now, I'm probably hugely cross-linked because, look at this, I've got all these that didn't come across with the project when I drag and dropped. It's linking them and showing them the dependencies, but they're not in the main project. So let's open these one at a time and file, save as, and I'm going to substitute the copy for the original. We've got it in two places. Let's do an additional copy here. And I do want to add it to this project where we're at right now. So we're going to click continue. It's going to ask us where we want to save this. Remember, we've got to move this from our example, my example folder, into my main project. Which this is not the orientation I usually see my files, and so let's shift this to where I can find things a little faster. And this step is purely, or this portion, the file order doesn't matter, but I can find it much faster this way. Okay, so the other thing you need to think about is this support? Is this, what type of file is this? Because you can just put them all in here, and that's perfectly fine, but you may want to sort them once you got it. With the sorted particle report, click OK, and it cannot open because an item is already in memory in the same, that has the same name. So now it's going to have an explanation point. It's because there's a conflict. So we tried to open two files with the exact same name. And a good way to get around this is to do this and rename it. So let's go ahead and do that. Let's go File, Save As, open the additional copy, continue. Now I need to go back to the other project. And let's give this, we can simply name this one 2017, but let's just put my in front of these, and or change the name slightly. Leave it as sorted particle report, but put your team number in here or something along those lines, because that'll designate it as your file. And click OK. And now notice we've got two versions of it open. And one of them should have my sorted particle report and one that does not. So close the one that does not have it. And the my sorted particle report should be now in here somewhere. Even if it's not, we bring up our folder. Here's my sorted particle report. We're going to drag and drop them in here. And I'm actually going to put them under support code, and just in the location in the project. And what I want to make sure is that we've got it set to the right location. So that is, if we look at the icons, it's an easy way to look at them. Here's the icon for that one, and here's the icon in our project. If I open it up, notice it doesn't say the My Sorted Particle Report. You can right-click it and replace. You go to All Palettes and select a VI. Go navigate to the My Sorted Particle and click OK. And you'll also have to save, but I'm going to show you in the project here. Our explanation point went away because we're no longer using that sorted particle report that was duplicated. And since I'm not going to use this one, I'm going to remove it from the project. Now, you do this for the rest of your VIs. I'm not going to take the time right at this moment to do that, but you do need to do that because otherwise you could lose these files if you reboot your RoboRio. One of them, though, that we do have to move and we do need to copy, but look at my example, is this calibration one. We've got to have that guy. So if we go, I don't think I can do it directly from here. Bring up my window, and I'm going to come back one folder and find my live demo, dig down to the files again, and here's that file. So I'm going to copy it and put it into my folder. Oh, way too far. Zero one and Control V. So now it's in here. And the other thing we've got to do is update our build specification down here to include that file. So if we look at source files, it's not even listed in the code. So click cancel on that. Let's look at the build specification over here. Go to source files. It shows it right there, and it shows it in the always included. The other thing it talks about, I believe, is in the source settings, it shows it is always included as well. So let me cancel this one and open this one back up. Let's double click it. Source files. Oh, it's not in my project yet. Okay, so cancel here. It's got to be in the project list for you to be able to include it easily. So it's all you've got to do is drag and drop it. I'm going to drop it in the support folders, or the support code folder up here. So now we've got it in the project. Now, see, where do they put it out here? They put it in the root beside the robot main. So let's just copy that. It's the same thing. It's in the robot main, or it's beside the robot main in the root directory on the target. Double click, source files, and now it shows up here. So we're going to tell it to be always included. Click on there, it's always included. And when we say OK, right click and tell it to run at startup, and it probably is going to give me the warning that I need to build it first, because I did not do that. If it's not been built, you must build it. So cancel and close. Cancel, deploy, because I need to build it. There we go. While this is building, does anybody have any questions? I know I'm moving fast. We are recording the session, and we'll send a link once everything's done. This is the first time this specific project has been compiled, so it may take it a couple more minutes than usual, or a couple more seconds, hopefully, not minutes. Okay, the build is done. As usual, run at startup. Deployment successful. Let's come back out to our robot main. And I know I've got a lot of windows open. I apologize. This one we're done with, so let's go ahead and close him. Minimize that one for now. And come to my robot main. Okay, one of the things too is I'm going to go ahead and change this to 640 by 480. And since I made the change, I'm going to make the current value default. The other thing that I already did that I didn't show you is that this is a default project, this enable vision button is not enabled, it's off. So I've clicked it, right? And then of course right clicked it, gone to data operations and made this value default. as well. And that will make sure that my setup matches what the test program was running at as well. So let's go ahead and run this. Notice I still have this division processing VI open in the background because I want to look at it and see how things are running. It says that there's already a real-time application running. Okay. Going through deployment. Because what I'm doing is I've used the run button instead of running it after a reset. Save the change. Save the changes in main. Okay, it is deployment completed successfully. Click close. And we are running. And there we go. So as I move my bottle, or excuse me, my boiler around, and yes, I am just that strong, notice it tracks it as I move back and forth across. All the way off the chair that I've got it sitting on. Okay, so the next question that most people will start coming up with is, okay, I've got this beautiful image, it's processing, it's targeting, how do I make something move? And that's going to be based on our pixels to center, either, well, pixels or the normalized values to center. And what I would say is you need to probably start thinking about converting these over to inches. And we're getting close on time, so I'm not going to explain that process specifically, but let's look at these pixels and use them as examples. Because what I can do here is these, I'll do it over here since you can actually see the whole thing. This is our image information that's coming from the camera directly. And we have the size information. If I mouse over it, it updates based on what my mouse position is. And if I look at my center position for this rectangle, we're at 365 and 330. So if I start left and right, 358, 65, well, that's pretty close to the center of that square, at least horizontally. My vertical number is 330. Let's start coming down, 311, 336, I'm pretty close. And yeah, let's see, make sure I'm still centered here. Should be off to the right a little bit, 365. So what that's telling me is that I'm pretty much right in the middle of my top bar is what's actually using for calculating the center of it, which is okay because we can use that information because now we know we have a point that we can start to adjust other objects like servos or motor controls to start pointing. We can get the number. I mean, if we want to know what the max value here, we can get our resolution, which should be 640 by 480, and I can't just quite hit right on the perfect pixel right at the second. But you can base it on your viewing angle, and vertical and horizontal to be vertical for your targeting up and down, and horizontal left to right for your moving your motors left or right, or moving the servo to target left or right more. You can then start using this range for power of your firing mechanism. To make sure that it actually fires hard enough or soft enough to lob it into the top of the boiler. And that's where you start to expand based on this initial example. Questions? We're almost at 7 o'clock. And that's when I said that the official presentation portion is going to end. And before we do that, I want to show you a couple links here. There's a good article here on the WPI library for the 2017 FRC control system. And it talks about what is the HSL and HSV, which is what we're partially using to do, or what we are using for part of the algorithm portion. It talks about mask. It's got some really good information in here on that. Another one, if you look at the workshops for last year that were at Championship, specifically, there are two in the technical resources. These two guys right here, integrating computer vision with motion control and the FIRST Robotics Competition Vision. These two are very, very, very good. I sat in on both those presentations, and there's some really, really awesome information. One of them was done by Team 254, and this is their website, team254.com, and I'm under their resources tab. And they have, this is the presentation portion that they did, and they've got the slides and a video of the web presentation that you can see and go together. This is very, 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 very good information. One of the things that they did with their robot, this is their robot right here. If you notice, he's turning left and right very, very quickly. And if you look at that camera and that targeting, it's pointed right at that target that entire time. Now, how he got this to work, he's using some pretty fancy vision and motion control portions, and they talk about how to do this. They give equations of how to make this work, and they explain the things they did to make everything go. This can be done with LabVIEW by itself. They're using, I think, an Android cell phone as part of the camera, and they're using Java and C to make everything tied together on their robots. You can do the same thing. You may not get this perfectly smooth as theirs, but I think we can probably work on it and get it pretty close to that just with LabVIEW and just with the RoboRio. Another one to look at is National Instruments, and if you go to ni.com/FRC, it'll get you into it'll drop you into the first area, and you can click on the robot competition documents. And the one I'm showing you right now is the 2015 image processing tutorial. It's got some good information in there as well. Chief Delphi, although it can be very, very helpful, it's sometimes hard to find the examples or find them in the threads that they were posted. But know that is a good resource as well. This is, if you type in, and I'll do it here real quick to show you, ni.com/FRC. This is the drop page that it gets you to. And usually I double click, make sure I'm on the documents or the discussions section, or the discussion sections where I'm pointing to right now. If you want to see the documents themselves, you come over here to the robotics competition documents, and that's where you're going to find, there's the quick start guide that I posted from the previous sessions. We've got an autonomous timed movement tutorial, software setup guide, and there's some older stuff, some very, very good articles. There's some stuff on the servo camera, command and control, all this good. This is all really good information for you guys to look at, and places to come for resources as well. So, questions. I know I went fast. That's 7 o'clock. I'm going to keep the recording going for the questions as we have them, but if you need to drop out for whatever reason, feel free. And we'll go from there. Does anybody that's in the room at large have questions? That's a really good question. Okay. He said that he thinks Brady is telling me that he thinks on his computer his licensing may not be set up properly. I know that was one of the questions that I saw in the forums. Let's look at how you check that real quick. So on my robot main, remember, please don't just hit the stop. Come down and hit the finish. It can help save some headaches in the future. Let's go ahead and finish this. Now, in any of the windows, yes, just a minute. Let me go through this, and then I'll unmute you, and we'll talk here for a second. On any of the windows, if you come to Help, and then Activate LabVIEW Components, this is going to launch the License Manager. And your License Manager should look something like mine. It should be dark green for all these specific buttons, and the ones we want to look at for the vision is the Vision Acquisition Software, this one, the Full with Vision Development, and the Vision Runtime. If any of these are a different shade of green or not green, you have a licensing issue. And all you've got to do is right-click it, and it should say activate, or I can actually deactivate one of these real quick. Well, if it's not, they'll say activate like this one. You click the activate, and you'll go through the LabVIEW activation wizard, and then you may have to restart LabVIEW once it activates. But that should enable it to where you can, if you're getting the error about the vision development or the one of the iMac or the camera, there's a whole list of VIs that would be not enabled properly if you don't have these modules enabled. Was yours? Yeah. So his was yellow. Did you right click and go activate? And you'll need a serial number that. Okay. And you can find your serial number if you check your professional up here, the professional development. If you click on that, it should give the serial number. I'm not going to click on mine because I actually have a different serial number in here, and I don't need to show that to the world right now. So anyway, but it should be based on the serial number that came with LabVIEW when you did your install in on the back of the envelope that came in your team kit. All right. Yes, let me unmute you. There you are. Okay, try talking. I think you're live. Try muting it. Unmuting it again. 2765. If you're talking, I cannot hear you. Can somebody else hear them? Am I just missing it? All right. If you're talking, I cannot hear you. Okay. Any other questions that anybody else had, or any other issues? So someone turn their camera on and off. Okay, no problem. Okay, Dalton, how would you go about sharing the results from vision processing VI to another VI such as autonomous? Okay, there are about 1,000 ways to do that, as with almost everything with LabVIEW. One of the ways that you can do it is with that global variable. So I bring up my vision processing, and the global variable I'm talking about. We have to add the vision. Yes, I can hear you. So where we were talking about earlier, we added the vision results in here. So I opened the front panel. You could actually share these vision results scores, are actually, by adding it in here, you have them available. At least the normalized and the pixel values are available to you already elsewhere in the program. And I'll show that to you. I'll go to autonomous. And I need where'd it go? Of course, I minimized it and I lost where it went. Right there. Okay. So bring our copy of our global down here. And all I did was I grabbed the icon. You can also go to your project and do the same thing. Mouse over for vision results, right click it, and change to read. And this is a cluster. So I'd come to my unbundle by name. And now we've got the same information that's located in here. So Dalton, does that answer your question? Excellent. Okay, 2765, you had a question?
Yeah, can you go back to the vision processing front panel?
Yes, I can. Close some of this. So it's not open actively. So the one that I created on my project or the example?
The one you created.
Okay, here it is.
So as you move it to the left and right, is the score changing? Is that right?
Let me run this and we will look and see and make sure I understand exactly what you're asking. Okay, so it's live. So, and you're talking about the score value, the yellow one right now?
Yeah.
Is that correct?
Mm-hmm.
Okay, so if I simply move it laterally, it is changing, but it's not changing significantly. I'm keeping the orientation pretty consistent as well. It will probably start to change as I shift it further away or give it a different angle. I think once we start.
So what I was trying to get to is, would you use the score to move the robot left and right? Because I noticed it changes as you move it left and right, but it doesn't seem to change significantly to use as a value.
No, I wouldn't use the score, not this score value, because this score is what this is for. Is if you end up with multiple targets or multiple objects that it detects in the window, this score value is which one do you want to use. And I don't have another piece of reflective tape with me right now, otherwise I'd show you. But you can end up with another target. Hey, well, I can show you one here in a second. In here, and the score value for the two will be different based on the targets identified. And so whichever one has the highest score is the one that it's going to try to target on based on the factors in this scoring VI. So it groups them. And this is what's dealing with the scoring right here. I believe so this one it gives let's look at the VI real quick. It's actively running. So we have sorted data coming in. We have it's trying to group and score things. And there's apparently a second object out there that it sees. It's saying that it's infinite. This one, the top score is the 94 one, which is the one that we're seeing right now. And if you had another object in the window, those would be listed down here as well for the different group scores. And so you could kind of get an idea for which one might be being selected. So the answer to your question though is no, I would not use the score value. I would use either the pixel or my normalized values. And I would actually, if I'm going to do this and use it for like active targeting, and what I mean by active targeting is your robot's going to be in motion and you're going to be trying to target at the same time, maybe have a gimbal that like the image that I was showing you, this video, or not video, but the short clip from 254's robot. This is what I consider active targeting, where the robot is in motion and it's still tracking and focusing on the target even while motion is occurring. Passive targeting is, does the robot stop and does it then make a decision and target? Or does it, if you're controlling the whole robot, is it controlling is the camera itself actively controlling your drive motors? Because effectively what you're doing is you're stepping through. My robot may be in motion, but it's probably not very fast. So I make a decision, move the motors, take another picture, make a decision, move the motors, take another picture. If you're using the passive, then the pixel count could be good enough to actually do your targeting for you. If you're wanting to do the active, you're going to need to be, and it talks about it in this presentation. If you go through this whole presentation, it's going to talk about getting the robot pose and linking it to, or not necessarily linking it, but keeping time with the robot position and pose effectively with each time you get a picture. Because then what you do is you link the picture with the pose that it was at with what my current pose is, and you correct your normalized values back into inches or feet or whatever you want there to get it to match, because there's delay in each imaging. We're probably getting, oh, it's actually displayed on here. Our loop second, this is running at 150, that was about 223, down to 14. this is in milliseconds, so we're talking about 0.15 to 0.2 seconds per image. And if you can make on-the-fly decisions that fast and be corrected based on motion of the robot with only about 10 images per second, you're a better programmer than me. And so the way you compensate for that lag is by using, like you'll learn that if you look at that other presentation, the robot pose of when the image was taken versus the robot pose of what I am in now, and doing a correction factor for what do I set my motors to, what do I set my servo for the gimbal to, or those factors to get it to stay on target even during motion. Does that answer your question?
Yeah. So like, I could say in autonomous, I would do the same thing how you showed in robot global data, send it over there, and then make constant corrections with each picture, basically.
Correct. And what you've got to think about is, big thing I'm going to tell you to do is don't do a ton of testing. If you decide to use the pixels and not use the robot pose, and I encourage you to look at 254's presentation on that, because you'll understand what I'm talking about when I'm saying a robot pose. But if you decide just to use the raw pixel count to do corrections, and so for example, if my target needs to be approximately, and I'll put my mouse on it just so we have a reference point. Say my target needs to be right where the mouse is to fire, and I'm over here. Well, I'm over here right now. What you can do is where my mouse is, where the white target is, the delta between the two, and you start to tell your motors to move, in this case, to the right. And so you're going to tell it to go a percentage of speed and start moving. The next picture may have you here. However, the next picture may have you all the way over here. And so what in that instance is happening is you've told your motor you're going too fast for the frame rate that you have in the pictures. And so what's going to end up happening, if you leave it like that, you're going to be constantly bouncing back and forth each image because you can never hit target. And so what starts happening is you've got to kind of figure it out. If I'm over here, I need to go to that with my white target, with where the mouse location is at. I need to move towards it, knowing how fast my frame rate is. So if I can only move at 0.5% speed, or with your joystick controls, that would be -1 to +1, and so maybe a 0.005, which means it's going to creep in on it. That's what you've got to do to keep it smooth. However, you can also go, if I know my distance is this big or greater than this number, go by like the rules of half. So try to move by half speed. So instead of 0.005, maybe you set it to 0.1, and the next image comes in and we're here. Now I need to make it move 0.05, and it gets to here, and then 0.05 as you slowly start zooming in on to correct to without actually overshooting it. And you can use that to some degree. You could use a PID loop to do that, but you've got to be careful with the PID loops, because you've effectively got two potential variables. One of them is the frame rate in which the data is being updated, and that you have to keep that in mind, because that frame rate's going to be, if you look at mine right now down here, this frame rate, it's 150 up to 225 millisecond update time differences. Your autonomous potentially can move a lot faster than that. So just keep that in mind. Your data updates are going to be variable, and it can cause orneriness if you're not careful.
One thing.
Any other questions on that?
Like lag.
I'm sorry, go ahead.
Would you want to maybe say if the camera's has like a 0.3 second or delay on there? Would you say move it and then set there and then put a weight on it and then wait like 100 milliseconds and let the camera catch up? Would that
Yes, you can also do a wait or watch until your values start to change. And once your values have changed based on this, like if you're using the pixel values, if it changes, then you know, and you've got to make sure, like if you can see right here, mine's just sitting still, and there's a little bit of motion down here. So what you're looking for is these major numbers to change. So if I'm going to reach over here and adjust it a little bit, where 541, I didn't move it a whole lot, and now we're up to 478. Or if I go the other direction, my motion here physically, I'm less than an inch, and you're getting reasonable motion numbers, real numbers, not decimal numbers, motion change. So you can watch for a change in motion before you do your next command. However, if you look at that other presentation by it's 254, I forgot the team number again. 254. They're getting, with this pose, you can get faster, you can make faster motions more precisely with this method of using the pose of the robot and then calculating based on where was I and where am I now in reference to the data that you get back. And the basics of what that is when you take a picture, if it's time, if it's linked to time, which you can do, and you know the position, my motor speeds for my motors, maybe the gimbal position, and maybe in degrees of the gimbal, and maybe you've got a gyro on there, so you're getting maybe a magnetic compass reading or just the gyro values itself. And if you're in motion, if I take a picture at time, we'll just call it time 0, and I know that information, and then my results from the image come back 200 milliseconds later, I'm in a new position. And I can calculate the difference between where I was to where I am. And even though it told me I needed to move to the right to get to this target by, say, 15 degrees to be on target, but if my robot has moved 5 degrees, the correction I now need to do is only 10 degrees. And that's how they're getting such smooth motion with not very good frame rates. It's using all that data, but it's correcting itself based on the pose of the robot. Does that help?
Yeah.
Good, good. Other questions? All right. I'll be here for a couple more minutes yet. If anybody else comes with a question or hasn't got it typed out yet, that's fine. I'm going this webcast will be posted along with the others, and I think if Ray's still on and listening, I think it's going to be in the same location as the previous video was posted as well. But again, I will get the link to that, and Harold will send it out. If you've linked in from a team that's not here in Oklahoma, from one of the posts that I did on the NI website, I will also try to catch those pages that I posted there, that you hopefully found it. I'm R² on the forums. If you see me out there, I will try to link to those posts as well for those questions that I hope I tried to cover today. If not, send me a PM on the NI website, or your mentors should have my email address, or can get it through Harold, or if you've got any of the Gordon Cooper team, they can get to me through there. And I think that's it. Good luck. I hope this helps. And yeah, have fun. I love this stuff. It's what I do every day of the week. But I love doing it in robots like this. It's even more fun.
I got a question.
Yes.
How would you use a gyro sensor to make the robot turn using vision? Like, how would you take? I know you would probably use robot global data, I'm assuming, to send that over, and then do some math calculation, and then tell the gyro to move so much.
So your gyro, it depends on which type of gyro that you've got and what information you're actually getting actively from it. Because the different gyros actually some have more data, some have less data. If it's simple, if it's like just a simple 3-axis or 4-axis gyro, you're getting information along the lines of the acceleration or the rotational speed that you've got. If it's some of the fancier ones, they may have like a compass reading, which is coming from a magnometer. And some of them do have even fancier options in there. So some of it's going to depend upon how that sensor is actively reading. But what I would do is I would bring it all to the same location. I wouldn't try to process the data from the gyro in the vision algorithm, I would probably do it live in, well, I say that. I may try to record my pose information all together in my vision algorithm. So in here, if we look at this, this is where we're getting the image right here. And so what I would start with is I would timestamp that image, but I would also make sure either I have a live running of timestamp someplace else of all my sensor data. So what is my, the gyro readings, specifically since what you asked about. But I would also do servo positions. I would also do maybe wheel positions. Whatever information I think I might need or I expect to need that has an impact on my targeting. And just off the top of my head, your gyro readings would be great. The wheel positions, if you've got, hopefully you've got encoders on them, so you know how many pulses in the pulse position when that image was taken. And you can start doing lots of comparisons between things. So then what I would do is, I've got that pose information is what that makes up. The gyro, the encoders, the servo positions is your pose of the robot when the image was taken. And so then all the way down here at the very end, once you've got data, which I believe is this spot right here, I've just put a probe, which is where your information is being coming out, I would compare, because now you've got to do a little bit of math to decide what are you going to do based on these results. I would use part of that decision process is what was my gyro reading and what is my gyro reading now to help me make a decision of how far I need to move based on the gyro results, the results of the vision algorithm, and I would probably look at the wheel encoders. I would look at my servo positioning, whether it be servos or another motor, all those types of information, bring it together to make a decision of how far and how much more do I need to keep moving to be on target. Does that make sense?
Yeah.
Okay. Does that answer your question?
Yep.
Sort of? Okay.
That makes sense. You would have to have a lot of information to be able to turn with the gyro instead of just simple gyro reading by itself to make it turn.
Well, and you can use, so the challenges with the gyro, a basic gyro, is it's just acceleration is what's really measuring. And so if I know I've got acceleration now, that's fine, and in what direction it is, that helps. But really what I need to know is what was I and what am I now? Because then between the two pieces of information, it gives me a clearer picture of the time between that I didn't take data. Or if you've got your pose information is more detailed, maybe like if this is running at approximately, right now we're between 153 to 200 some odd milliseconds. Maybe your pose information is down to the 10 or 20 milliseconds or 50 millisecond time frame. You can look at in smaller samples of time, because then you've got information you could act on. So if I knew between time 0 and time 50 milliseconds, I had no acceleration, and then from time 50 milliseconds to 100 milliseconds, I had left rotational information or acceleration, and then from time 100 to 150, or for the rest of it, I know that there was a small portion of time where I was in motion. And so that's something I need to either correct or at least be aware of, because rotational motion is important to targeting. And that happens between the previous image and my results coming out. So that's changed my targeting values of where I am at now versus where the image was taken. So you can use the gyro to give yourself information. It's just, it's not simple. It's not just acquire the data and now give me the answer type thing. It's, I've got to have the data, and I've had it saved a little bit so that I can then make an intelligent decision of what needs to happen next.
And with that, could you say, you know how you're saying the camera can image can lag, so you may be one spot over here, but then you may be way over here. Could you say, what if the gyro senses a great increase of 30 degrees and then you could tell it to exit the loop if it starts to go back and forth like you're saying, how it would never get to the position. You could use the gyro to exit the loop. So like say if the gyro if it reads an increase of 30, and then by that time it's went way over, and then it might start just doing the loop over and over to tell the loop to turn false.
Well, so okay, if sort of it was the short answer. Yes, you could do it like that if you see a large jump. However, if you're like, if we're far, I'm moving the wrong direction here. So if we're far off the edge of the target here, and the algorithm said, oh, we need to move to the right a lot, and so I'm going to give quite a bit of power to the motors just to here. I mean, from depending on how far or how close you are to the target, that may be 15 degrees. That may be 1 degree based on the positioning, because that's 1 inch change. I mean, obviously you'd not be seeing it from that angle. You'd be seeing it, where's my perspective here? You'd be seeing it something like, ooh, I'm getting too far away. Something along these lines, which of course is having a hard time with the algorithm right at the second because I'm not square. But you would, from there to there, may be a significant number. And so how much is enough and how small is enough? Because you've got to think about not only how big of a change, but how small of a change. Because if you're getting to it, if it's going to take 15 seconds to get to target to fire, why are you doing it? Why is it's not fast enough for autonomous? Does that make sense?
Yeah. Like, what
so you've got to think about both sides of it. And part of it would be if you've got these numbers corrected, if you're using the pixels, or if you're using your normalized data and corrected to actual, because what I would recommend is you convert this from the normalized data into actual, how many degrees do I need to rotate if it needs to be degrees, or how many feet do I need to travel to be on target. So if you can start thinking about it in real numbers, then you can take a gyro reading, which may give you degrees, like you're heading. Maybe I'm headed due north, or I'm headed at 45 degrees, or you can start comparing degrees to degrees, basically. And then you can start looking at is from image number 1 to image number 2, it said I needed to be, or at time 0, and now it processes the image, and now I've got at time 200 milliseconds, I have an image results, and it says I need to move to the right 10 degrees. And I tell the robot move 10 degrees. When it's done and I've got the next image and it says I need to go left 10 degrees, suddenly my motion, obviously I'm probably in a cyclic loop. Like you said, I'm oscillating back and forth and I can't hold target. Instead of telling it to move 10 degrees to the left, I would probably have told it to go 5 degrees. And if it said I now need to go 2 degrees to the right, I'd tell it to go 1 degree to the right. And because then I'm reducing the amount of motion each time versus trying to hit perfect every single command. Does that make sense?
Yeah. Like I would have like a button for like teleop to tell it when to start calculating, so then it doesn't have to make like crazy amounts of changes. But I know I'll have to test and figure out what the maximum change can be, and yeah.
And that's a good way to do it. The other thing is that once you get to that point, if you're recording pose information, you can probably have that calculating live, but not connected to the motors directly. So even if you're not ready to fire, or if you're not there, if you're already processing the data live, first of all, you know what your CPU load is going to be on the Rio, and you're not worried about being at 100% all the time. The second side of it is that you can be looking at and thinking about or you can be tuning the algorithm during each practice session as well, because sometimes you can get it to where it's a little bit on the, I'm thinking of two things here, sorry. I wanted to show you guys one more thing while I was thinking about it. But so if it's live processing all the time, you just don't have a target. It would basically force you back into, if you're in teleop, force you into, instead of being remote controlled, instead of being robot controlled or autonomously controlled, you're still in the teleop human controlled mode if it doesn't have a target. And I would put a big old indicator on my the dashboard somewhere saying, I'm not in auto mode here. I'm in you should have control. So that way, you know, if I'm getting ready to push the button, I look down and it says the target and it's trying to control it, I know it's going to take control. And if for some reason that light comes on when I think it shouldn't be on, then I can let go of the button and keep moving. I can manually move the robot. But that way it's telling you, I think I could control it if you want me to, or I've lost control and I need you to do something for me. Because you could be hit just the perfect second when you pull the trigger to let the robot control itself. You could get hit broadsided by another robot and suddenly the image isn't even in the picture anymore and it doesn't know where to go. So those are all things you just need to think about and try to manage actively. One of the things I wanted to show you real quick, let's see. This is the PC. I want the RoboRio, and I've forgotten where to look for that. Oh, of course, it stopped working. Live demos can always be interesting here. But what do you want to look at when your robot's running? Somewhere there is a reading for what your robot oh, it's over here in the statistics. So the CPU cycles here. Notice I'm getting kind of high on the CPU cycles of what's going on with the RoboRio, and some of that could be encouraging this millisecond delay here. So if your algorithm gets too complex or your math is getting too crazy and you're reeling, the CPU is just sitting right at 100%, 100% of it all the time, you need to start making some changes. And some of that could be to slow the frame rate down a little bit. And you can do that. Remember here at the very beginning, we've got set the frame rate. You may need to change that to lower the frame rate down a little bit if you're doing all the processing on the RoboRio. Now, the other thing you could do is you could offload some of that processing to your driver station. And that is another conversation all in itself of how to do that and how to make everything work and talk back and forth and everything. But know that it is possible and it can be done. But that's just something to kind of think about, is don't forget to check what your CPU usage is, because especially if you're starting to get jitter response, maybe you do it based on a trigger like you were talking about, how it only tries to process when I pull the trigger, or it has a really, really slow frame rate until I pull the trigger, and then it speeds the frame rate to as max as it possibly can go. So those are some things you need to think about and at least be aware of, because that can have a direct impact on the performance of the robot. The other option, I'm not sure I can quickly find, I think they talk about it briefly. You can offload some of the processing onto a secondary computer. And a really good example for if you want it and can get it, this is one of the, may not be the one I'm thinking it is. Oh, that's the presentation I was just looking at. PDF. That's not it either. I'm not sure where I found it. Was looking at so much earlier today that I've lost track of where I found everything. Oh, you know what? It's right here. So one of the options you can use is, okay, so you could potentially use a Raspberry Pi or something along those lines to do vision processing. One that I would probably point towards and try to go for is like this is a Kangaroo computer right here, this image it's got here. That one can be a really good option. There's like the NVIDIA PK1. All of these will have varying levels of degree of complexity to make it work and get it to work consistently. But know that that is an option for a secondary CPU on your robot that's actively running vision code, and you can communicate to the network tables. Because like on the Kangaroo, and the reason why I point at that specifically is that you can run LabVIEW on it directly and run almost this exact vision code on that Kangaroo. And then you could just be feeding results back to the network data tables or the shared variables, just like we are over here with these vision results, just like this. So that's an option. Anything else?
Hey, is there a limit on how many CPU like computers you have on your robot?
I think there's a weight limit for the robot. Beyond that, I don't think there's a specific limit. What you do have to be concerned about, though, is battery power and usage. You could effectively have unlimited CPUs if you can afford them and get them. But I think the two things that are going to end up starting to limit you is your each computer has weight, so obviously your weight limit eventually, but then your battery usage. You may get to the point where you need a battery per round effectively, because one of the things with vision processing is it will use as much CPU as you can let it have. And that's why without active limiting, I'm running close to probably in the high, I'd say that's probably in the 90s, high 80s and 90% range right there without doing anything specific to look at the actual number. And so that's just something you need to think about. How much CPU do I need for other things to make my robot do what I want it to do effectively? And so, yeah, add more CPUs is a good way to get there. Make it faster, make the image frame rate faster, which means faster results, which means easier to process data. The other side limiting factor can be dollar value. The Kangaroo is only $100, but how many times do you spend $100 before suddenly you're out of budget? So those are all things to think about and to consider. The other thing you can also think about too is some of these may be easier, some of those targets may be easier to do in non-LabVIEW environments. And my mind just totally went blank with what it's called. The grip application, and they've got, it runs Java and C++. You can make that work on some pretty lightweight targets like the Raspberry Pis. And if you decide to jump it to Linux, you can actually get the Kangaroo to perform a little faster with the grip, with either the Linux version of Windows. I don't think you can do all of LabVIEW, but you can do grip on that and get it to process, I think, a few frame rates per faster as well. It would be something would be interesting to experiment with. And I'll probably do after the season's over, but not right now. Does that answer your question?
Yep.
Good.
Hey, thanks
Anything
for helping information.
You are very welcome. I'm glad I could be of help. Good luck for all of your robots, everybody. I hope to see people using more vision this year. If you've got questions, reach out to us. Reach out to me. I think my contact information may be in a beginner session that we did, was it last week, week before? I lost count now. But once we get the link to this one, if you don't have that information, you'll see the links to the beginner session as well, and in the advanced section I did before this as well. If that's it, if there's no more questions, then I'm going to sign off. Well, thank you, everyone. Thank you for the questions, and I hope it was worth it for you. Good luck for this season, and hope to see you at regionals and hopefully also at nationals. Good luck, everyone.